Right, so today we are starting refraction of light at plane surfaces. We have studied reflection of light in class 9, right? Can somebody tell me what all do you remember? What were the laws of reflection? Quickly, what were the laws of reflection? We studied it in class 9. So we quickly recap it and then we move forward. Anybody? What were the two laws of reflection that we studied in class 9? Okay, there comes. Kritika says, sir, now our syllabus changed. Okay, chapter 3 is not coming. So good for you. Okay, so we don't have to worry about Kritika now. Okay, anybody tell me the two laws of reflection? You remember them? We studied in class 9. The Shingarika says angle of incidence is equal to angle of reflection. Very nice. One law we studied was that the angle of incidence is equal to angle of reflection. And the other one, that's a Kratika. What does she say? I'll have to put my reading glasses. I can't read. It's so small.
I is equal to R.
Don't worry. I'll use this. Okay. Now Shingarika says. No, Shingarika, you have brought refraction. We didn't study refraction in class 9. We studied only reflection. Okay. Anushka also says angle of incidence is equal to angle of reflection. The second law which we studied was that the incident ray, the reflected ray, and the normal all lie in the same plane. Okay. So those were the two laws of reflection. Okay, and that was when light is incident on a polished surface, it bounces back into the same medium. That was reflection. Now we're going to do refraction. Let's understand what is refraction. Okay, so first of all, let's again recap that the speed of light in vacuum is the greatest. Okay, the speed of light in vacuum is 3 into 10 to the power 8 meter per second. All of you know that. Okay, and the speed of light in air is slightly lesser than this. It is almost the same, very negligible. Okay, so we take the speed of light in air also to be 3 into 10 to the power 8 meter per second. Now we know that there are three kinds of medium. One is transparent, the other is translucent, and the third one is opaque. Okay, opaque light cannot pass through. Translucent, some light can go, okay, and transparent light can pass through it. Okay, all of us know that. So now the second thing which we should note is that the speed of light changes in other transparent medium. Okay, it is the greatest in vacuum, and if it goes into some other transparent medium like a diamond or a glass, then the speed changes. Okay, and we are going to study about that only. Okay, refraction is a surface phenomena, which means it takes place at the interface of two mediums. On one side we have some other medium, medium 1, on the other side we have medium 2. Okay, both are different, and this is a transparent medium, so light will go through the medium, but the speed of light will change when it goes into the other medium. Okay, so first of all, let's understand that it is when light strikes, okay, it is partial reflection and partial refraction, which means the whole of light doesn't go into the other transparent medium. Okay, obviously you look at water standing near a lake, or near, when you go to the village, in a well, you look into the well and you will be able to see your reflection there, right? Which means that the upper surface of water is behaving like a mirror, which means that light which is going there is bouncing back. That's why we can see our virtual image in water, right? So let me pick this up. Okay, so let me show you. Okay, I have a glass slab with me and I have a laser with me. Okay, now I will put this over here. Okay, I will hold the glass slab over here. Now you can see glass slab is as good as water. It is a transparent medium, but this surface is quite polished, which means it should be able to make the light bounce back into the same medium, right? So let's see whether it makes it bounce and whether light goes through it or not. Okay, here I put my glass slab and I direct my laser. Can you see that this laser over here, you see it comes back? Can you see that there it is coming back? Okay, and I can see it going through also. You can see that it's going through also. It's bouncing this side. Okay, it's bouncing this side. There you see it's bouncing this side and it is going through to the other side also. Got it? So light is partially getting reflected from the interface, from the boundary of the second medium, and partially it is going in. Okay, so you tell me the intensity of light which goes into the second medium, will it be the same? Will it be greater? Will it be lesser? Waiting for your answers. You know, my classes are like this. I like interaction. So your question is, now that we have seen that the light is getting reflected and it's going into the other medium also, so the intensity of light, the amplitude of light which is going into the second medium, is it same, lesser, or greater?
Same.
Waiting. Okay, Shingarika says same. Okay, what all have you retracted, girls? So many messages retracted. Okay, Shingarika has again retracted it. Why do you keep on retracting? Not retract. The wrong answer is gone, then let it go. Don't worry about it. It depends on denseness of medium. Anushka says depends on denseness of medium. Okay, and then Shingarika says decreases. Okay, when medium is denser. Okay, Kritika says same. Shingarika says increases when going to a rare medium. I asked you about the intensity. Okay, intensity. Now if a part of light is getting reflected, which means that the light which is going into the second medium has to be less intense. Okay, because a part of light has been sent back to the medium and only a part of the light, other part is going into the second medium. So the intensity of light which goes into the second medium is lesser. Okay, at present we are not talking about denser or rarer. Now the girls who are writing denser and rarer, we'll discuss one more thing. Remind me if I forget. Okay, if you write only denser, I will not mark it correct, I will mark it wrong. Okay, so when we go there discussion, you have to tell me. Okay, so now you see, now S dash is the interface, the boundary of two mediums. This is medium 1, this is medium 2, and OA is the incident ray. Okay, this is the normal N dash. Got it? This is a normal N dash. And you know, next question which comes to you is what is the angle of incidence? What is the name of angle of incidence over here? You can start writing. In the meantime, I know it will take 30 seconds for you to reach the video. Till then I can continue. Okay, so in this diagram I've already marked angle of incidence. Okay, angle of incidence is the angle made by the incident ray with the normal, which means the name of angle of incidence is angle AOM. Has something come? No, nothing has come till now. Okay, so the name of angle of incidence is angle AOM. And now, obeying the laws of reflection, as I showed you using the glass slab, some of the light bounces back into the same medium. Okay, कुछ लाइट रिफ्लेक्ट होके वापस उसी मीडियम में लौट गई. अब इसमें वो अपने लॉ ऑफ रिफ्लेक्शन फॉलो करेगी. एंगल ऑफ इंसिडेंस विल बी इक्वल टू angle of reflection, and all three you can see are lying on the same plane, the incident ray, the normal, and the reflected ray. Okay, now this partial reflection has taken place, and a part of light, partially light has gone into the transparent medium. Okay, now light follows in a straight path. Rectilinear propagation of light, all of us know it travels in a straight path. Okay, but now we see that light should have gone along this dotted line, but light has bent towards the normal. Okay, it has bent towards the normal, which means light has bent at the interface, at the boundary. Okay, so the next question which arises is, why has it bent? So some girls were writing, okay, about the density decrease in medium 2 because of the density. Now let me clear one more thing. Okay, when we are talking about refraction, we refer to a term known as optical density. Okay, we refer to a term known as optical density, and this optical density is not the same as mass density. Okay, mass density, we know that mass density is equal to mass by volume. I divide it and I get the density. Okay, but optical density is not the same thing. Okay, how can I prove this to you? I take example of oil. Okay, I take example of oil. If I have a glass full of water, okay, if I have a glass full of water and now I pour some oil into it, will the oil go to the bottom or will it stay on top? Will the oil decrease in medium? Nobody's writing now. Okay, will the oil travel to the bottom or will it float on top? Quickly, I'm waiting for your answers now. Will the oil float on water or will it sink to the bottom of the glass tumbler? All of you have must done this sometime or the other. Okay, all of you stay on top, says Kratika. Anushka says stay on top. Kanishk says it will float. Shingarika says on top. So all of you are correct. Congratulations. It floats. It floats. Okay, this black thing is oil. So it floats. Now if it floats, is its mass density less than water or is its mass density greater than water is the next question. You people must be telling me, he keeps on asking questions. I like it this way. I like it this way. When children are answering, I know they are learning. Okay. So quickly, is the mass density of oil greater than water or is the mass density of oil less than water? Waiting for your answers. Here comes Shingarika. Less than water. Obviously, if it is floating, it means its mass density is less. That's why it is on top. Had its mass density would greater, it would have sunk to the bottom. Okay, so we get to know that density of oil is less than density of water. Okay, all of you agreed? Now we take the same two mediums. Okay, now we do the same thing. Okay, now we have a tumbler. Okay, and we have water at the bottom. We have water at the bottom and we have oil on top. Okay, we have oil on top. So this is the interface. I've drawn a line just to mark the interface. Okay, now this is a glass tumbler, so easily I can direct a laser from underneath it like this, right? So I direct a laser from underneath it, which means my ray of light travels like this. Okay, I'll bring it a little this side. My ray of light travels like this, and now this is the interface. Okay, this side I have water, this side I have oil. Black and blue also are telling us. Okay, so now what happens to the light? Question, another question. What happens to the light? Okay, ideally it should have gone like this. Ideally it should have gone straight like this. Now my girls tell me, what happens to it? What happens to this ray of light which is traveling from water to oil? Let's see, what do the girls write? Quickly, waiting for your answers. Now this is an interesting one, so I'll wait for your responses, only then I proceed. तुम्हारे जवाब आएंगे, उसके बाद कहानी आगे बढ़ेगी. तो जवाब जल्दी भेजिए. Bend away from the normal. Okay, Shingarika says, Kratika says, it will bend, Kratika, everybody knows that. where will it bend? Will it go towards the normal? Will it go away from the normal? Like Shingarika says that it goes away from the normal. Okay. Anushka says bends away from the normal. Okay. Ayush Kumar Dikshit says deviates away from the normal. Okay. So all of them say that it bends, except Kratika who just says bends. Take it anyway. Whatever you give the answer, mine will be right. Okay. So now I tell you that the speed of light, once it enters from water to oil, I see that my light has fallen. My light has fallen towards the normal. It has not gone away from the normal. Okay, light has not gone away from the normal. Okay, which means that the speed of light reduced in oil, which means the speed of light reduced in oil, which means that oil is optically denser than water. Okay, so I write optically denser. This was mass density. This was mass density. Mass density of oil is less than water, but optical density of oil is greater than water. Okay, so we relate. Somebody says something. Kanish says bends away from the no. All of you got it wrong. It bends towards the normal. That's why I said I'll take this example and then you'll get to know that both the things are not the same, and then you will stop writing density. Most teachers give it a correct also. They give it a correct mark, but I am very strict about it. If you write only density, I cross it generally, because through this example you can see that both are contrasting things. On one hand, the optical density is greater than water. On the other, mass density is less than water. So what is optical density? Optical density I talk when I am taking two mediums. Of course, refraction takes place when I have two different mediums. Okay, so in these two mediums, if light is traveling from medium 1 to medium 2, and the speed of light reduces, I say V2 is less than V1. Okay, the speed of light reduces. If the speed of light reduces, then the light falls towards the normal. You can see this delta is the angle of deviation, and how much is this equal to? Delta is equal to I minus R. Okay, why I minus R? Because my I is greater than R. You can see that vertically opposite, this is equal to I and R is smaller than this. Okay, so my delta is I minus R, which means my ray has deviated towards the normal by this angle delta, which is equal to I minus R. Got it? And why has it deviated? It has deviated because the speed of light in medium 2 is less. So if the speed of light in a medium is less as compared to the other medium, we say that medium 2 is optically denser than medium 1. Got it? Optical density, whenever we talk about optical density, we talk about it in terms of speed of light. If the speed of light is greater, we say that medium is rarer as compared to the other one. And if the speed of light in the medium decreases, then we say that the medium is optically denser than the other one. In this example, suppose we take this as glass, okay, and we make this air. So because the speed is dropping, so we say that glass is optically denser than air. If I talk about air, I say air is optically rarer than glass. Everybody understood? I get my thumbs up after so many days. So happy. Anushka says understood. Thumbs up. Hey, give me a like there also. I don't see a like over there. One like I see. I don't know who has put. Anushka only must have put. I see one like only there. Okay. So if you have understood the difference between optical density and mass density, give me a thumbs up and press the like button. Okay, we proceed further then. I'm waiting for your likes. Let the lights go up and we proceed then. Okay, so we have discussed optical density, we have discussed partial reflection. Okay, we have done most of the things. We only missed out. Okay, now we reverse it. Okay, now we reverse it. I erase all this. I erase it. Okay. Now I change the mediums. Okay. Now medium one this time becomes glass. Okay, and this becomes air. I have flipped them. Okay. Now I am directing light from glass into air. Okay. So now what is going to happen? Shingarika says, awesome. Good. The likes also have gone up. Thank you very much, girls. Okay. Now I'm so sorry. I forget that there are some boys also because it's the girls who keep on answering. Okay. One boy also was answering. Who was it? Ayush Kumar Dikshit. Ayush again answers deviates away from the normal. Okay. Ayush, wonderful. Ayush, I remember you are the only boy who's answering. Okay. So now Ayush says it bends away. Why does it bend away? We know that glass is optically denser as compared to air, which means air is optically rarer as compared to glass. Okay, so if light is coming from a denser medium to a rarer medium, the speed will go up. Okay, and if the speed will go up, it runs away from the normal. Okay, which means my light goes somewhat like this. So this time my OB is over here. Okay, which means this time my angle of refraction is this. Okay, which means that this time my angle of refraction is greater than angle of incidence. In the previous case, my angle of incidence was greater than angle of refraction, but in this case now my angle of refraction is greater than angle of incidence. Okay, why is it so? Because the speed of light in air is greater than the speed of light in glass. Got it? So you have understood? Okay, and in this case now my delta becomes r minus I. Okay, this is again the angle of deviation, and this time becomes r minus I. Okay, why r minus I? Because r is greater. Clear? Everybody understood till here? Give me a thumbs up. Give me a thumbs up if you have understood. Shingarika says deviation is equal to r minus I. Thumbs up from my side to Shingarika. Okay, Anushka says away from the normal. Thumbs up for that. Okay, we continue now. If you have understood, give me a thumbs up and we continue. From now onwards, okay, I get the thumbs up from Anushka. I don't know what was that, Kanishk. I don't know. I'm very poor at these smiley things. I don't understand. I'll find out today and then I'll revert to you. Okay. Now, from now onwards, we have seen by doing a practical also that light actually partially gets refracted, partially it gets reflected. But now we will not go into the partial reflection. We will focus only on refraction. Okay, so from now onwards we are going to study as though light will only get refracted. There is no reflection, partial reflection going to take place. That's how we are going to proceed. Okay, so now I have now a ray of light which is incident like this. a ray of light incident like this. Okay, all of you can see that. Next question, what is the angle of incidence? How much, how much is the angle of incidence? Okay, I don't want the name. Anushka gives the answer. It will pass in undeviated, I know that, Anushka, but first you tell me, what is the angle of incidence over there? What is the measure of the angle of incidence over there? Shingarika says it will pass undeviated. Anushka says 90 degree. Okay. Anybody else? Ayush Kumar Dikshit, I love you. Okay. He says 0 degrees. And Ayush is right. Okay. Kritika says 90. And Archika says 0. Anushka now comes back to 0. Okay. It's not 90 degree. Okay. I told you that what is angle of incidence? The angle of incidence is the angle made by the incident ray with the normal. Okay, so this is a normal. I have one line over here. Okay, I have to have two lines for making an angle. Okay, this is one ray, this is the other ray. Now one ray is this one and the other ray is on top of that. You saw the blue ray and now the black ray is on top of that. What is the angle? The angle is 0. Okay, they are not making any angle. One ray is on top of the other ray. So here also the normal, and on top of that I have the incident ray. So the angle of incidence is equal to 0 degrees. Most children write it 90 degrees. Okay, don't write it 90 degrees. If somebody asks you what is the angle of incidence and you write 90 degree, it goes wrong. Okay, this ray is incident normally to the surface. This ray is incident normally to the surface. मतलब ये surface के साथ 90 डिग्री का कोण बना रही है. It is incident normally to the surface, which means its angle with the surface SS dash is 90 degree. But its angle of incidence is not 90. Its angle of incidence is 0. Okay, and my girls told me that it passes undeviated, and they are absolutely right. Okay, the ray of light passes undeviated without bending. Okay, now the next question which comes to mind is that it means that refraction takes place only when the ray is incident obliquely. Obliquely का क्या मतलब है? लिखो. Obliquely का क्या मतलब है? Angle I is equal to angle R is equal to 0. Okay, nice. Now obliquely का क्या मतलब है? जल्दी से लिखो. What does obliquely mean? I say that refraction takes place only when light is incident obliquely. It doesn't happen when the light is incident normally to the surface or when the angle of incidence is 0. Okay, so what do I mean by obliquely? Waiting, come on girls, quick. What does obliquely mean? Waiting for your answer. There comes Shingarika says not 90 degree. Not 90 degree to the surface. Okay, obliquely means it is inclined to the normal. It is inclined to the normal. Okay, so Shingarika says not 90 degree, we'll give it. It comes at an angle. Okay, when the angle is 0, then it is normal to the surface. It has to be oblique, which means it has to come at some angle to the surface. Okay, it should not come perpendicular to the surface. Only then it takes place. Now the next question comes is, why is it so? Why is it so that it takes place only at when it is coming obliquely and not at 90 degree? Okay, so for that we consider the wave-like motion. We consider the wave-like motion of light. Okay, now here is light coming. Okay, and I am making these waves. So you can see all of them have a specific amplitude. Okay, and it is not changing because the speed is not changing, and the frequency of course will not change because frequency is dependent on the source. Now at this place where the light is going to strike, okay, this was the width. This was the amplitude. So now I can see that this wave is half in the other medium and half in medium 1, half in medium 2, half in medium 2. Okay, now in medium 2, its speed is decreasing, but its frequency is not decreasing. Okay, which means its wavelength decreases. Got it? So now the wave comes closer like this. Okay, the wave comes closer like this, and now it is still away over there, and now it starts going with a lesser amplitude. Now it starts going in this direction. Got it? So I can see that now the light has bent. You can see that at the interface it bent. Had it been incident normally, okay, the amplitude is greater, the wavelength is greater. Now the whole wave goes in one go into the second medium. So even though it has decreased, but its direction does not change. Even though the medium has changed, you can see that the wavelength has gone down. Okay, but still it continues to go in the same straight line. Okay, because the whole wave goes into the second medium in one go. Here it's going partially. A part of the wave is in this medium, a partial of the wave is in that medium. Okay, we can take one more example for this analogy. Okay, I take let me rub this. Okay, now I have this side road, GT road, okay, which is very well maintained, and this side I have a sandy road, kacha road. Okay, now I have a car coming. Okay, I have a car coming, and it is coming like this at an angle. Okay, it is coming like this at an angle. So when the car is here, you can see that one wheel of the car is in sand and three are still there on the road. Yes, no? One wheel is there in sand. So the one which is in sand, what happens to it? It gets stuck. It moves slowly. But the other three are still on a road which is offering quite some friction, and so they go zoom. So what happens to my car? My car turns like this. Okay, till the other wheel also is in the sand. Now when the other wheel is in the sand, then my car starts going in that path. Got it? So it's the similar way. If it is falling obliquely on a surface, okay, then because of change in speed, the light bends. If the speed decreases, it falls towards the normal. If the speed increases, it goes away from the normal. If it is incident at an angle of 0 degree, which means if it is incident normally to the surface, then it passes undeviated. Once I have done Snell's law, the laws of refraction, then you can remind me there mathematically also. I will prove it to you why the light goes undeviated when it falls at 0 degree. Right? We have some time? Yeah, we have.
10 minutes.
Okay, we have 10 more minutes, so we proceed. We go to laws of refraction now. This we have done, normally we have done. Okay. Everybody understood causes of refraction? We have discussed causes of refraction. What is the cause of refraction? Quickly, let me listen to you. Slantwise. Okay, slantwise obliquely was the correct one. Vaibhav. Shingarika says, okay, she gives me the law of refraction. I asked you, what is the cause of refraction? Have you understood the cause of refraction? Everybody give me a thumbs up for optical density. Okay, if you have understood optical density, you should have understood the cause also. What is the cause of refraction? Quickly. Yeah, their change in speed, says Ayush Kumar Dikshit. Ayush, you are wonderful. Okay, I love your answers. You're the only boy who gives me. Now somebody joined in. Now Vaibhav Mishra joined in. Okay, so Ayush, now Vaibhav also is with you. So Ayush tells us that it is the change in speed of light which causes the bending. If the speed decreases, it bends towards the normal. If the speed increases, it bends away from the normal. Okay. So now we go to laws of refraction, and Shingarika has already written it to us. Laws of refraction. Okay, the first one is very similar to that of reflection, which says that the incident ray, the normal to the surface, and the refracted ray all lie in the same plane. Okay, which I have showed it to you also. Okay, here you see, now this is the glass slab and this is the incident ray. You can see that the incident ray, okay, and the refracted ray, the refracted ray is coming on the other side. You can see that all are lying on this board itself. It's not that my refracted ray when it is on the, when my incident ray, when it is on the board, then it is not happening that the light is coming out of the board into a different plane. It is staying in the same plane. Okay, you can see that here is my incident ray over here, and here you will see the refracted ray. Both are on the same plane, and of course when I draw a normal to this edge, it will also come on the board. So the first law is very similar to that of reflection, that all three lie on the same plane. The second one, in that case we had that the angle of incidence is equal to angle of refraction, but we have already seen that in this case they are not the same. Okay, if the medium is denser, then R becomes smaller, and if the medium is rarer, then R becomes greater. So what is the law? Snell gave this law to us, so we also call it Snell's law. Okay, this is angle of incidence with the normal, and this is angle of refraction with the normal. Got it? So for a pair of medium, okay, this is not true for any medium. Okay, I have to have a pair of medium 1, medium 2. Okay, say this is air and this is glass. So for a pair of medium and for a monochromatic ray of light, which means light of only one color. Now, different colors of light also bend to different extent, which we'll study in the next portion. Okay, at present we just remember that it has to be color of a light of a single color, and for a pair of mediums. Okay, what does Snell say? He says that the sine of angle I, the ratio of sine of angle I to the ratio of sine of angle of refraction, okay, it is always a constant. It is always a constant, which means if I keep on changing the angle of incidence, accordingly the angle of refraction also will keep on changing, but the ratios of sine of angle I to sine of angle R will always be a constant. This is Snell's law. Okay, and we call this constant refractive index. We call this constant refractive index of medium 2, which means the one which is at the bottom, which means the one which is at the bottom of medium 2 with respect to medium 1. Got it? Okay, let's take an example to understand it better. We have already taken air and glass. Okay, we can relate it. One more thing I do, and then I go back over there. Okay, this refractive index also can be expressed in terms of speed of light. Okay, this mu 2 1, I can write it like this mu 2 1, I can write it like this mu 2 1. If I write only mu 2, then it means that it is the absolute refractive index. Okay, so this I can write in terms of speed of light also. Mu 2 1 is equal to speed of light in medium 1 upon the ratio speed of light in medium 2. Got it? If I am talking only mu 2, which means absolute refractive index, then it means it is the ratio of speed of light in vacuum or air, which is 3 into 10 to the power 8 upon the speed of light in medium 2. Got it? Everybody understood? So we can relate this, we can express this also in terms of speed of light in the two mediums. Clear? That's all for today's class. We got just 2 minutes more, so we cannot go any further. Now let me take a quick recap. Let me take a feedback. Everybody understood till here? Give me a thumbs up. Anybody has any query can punch in so that I can start my next class by answering that query. All of you have understood refractive index, Snell's law, okay, and all of you have understood refractive index in terms of speed of light in the two mediums, right? Yes, no? Waiting for your comments. Anushka as usual says thumbs up. Shingarika as usual says wonderful. Okay, others? So what is absolute refractive index? Kritika puts in a question. She says, sir, what is absolute refractive index? Kritika, when we are comparing the speed of light in a medium with respect to speed of light in air or vacuum, which is the greatest, okay, and refractive index will always be greater than 1, because in no other medium the speed of light can be greater than the speed of light in vacuum or air. Okay, so if I am comparing the speed of light in a medium with that of speed of light in vacuum, then I call it absolute refractive index. I express it only as mu g for glass. I don't write anything else. Okay, if I'm expressing relative refractive index, then it becomes two mediums. So if only one medium is written, it means it's absolute refractive index, right? Two definitions are given. Which one to write? Let me check the definitions quickly. The above says two definitions are given. Where is it? Give me the page number. They found it. Okay. The refractive index of second medium with respect to first is ratio of the sine of angle of incidence to the first. Okay. And where's the other one? I don't see two. I see only one. Where's the other one, above? Okay. If they ask you Snell's law, you have to write only in terms of sine of angle I upon sine of angle R. If they want you to express refractive index in terms of speed of light, you can use either of the two. You can put in the sine of angle of I upon sine of angle of R, or you can express it in terms of speed of light in the two mediums also. Right? Anything else? Done. That's it. So thank you, children. I hope you enjoyed. I had a lovely time meeting you after so many long days. And I hope you are recommending the channel Wisdom 360 to your friends also. Please do like. See, so many were attending, and look at the likes. Come on, be generous. Bye-bye. See you.